This journey begins over 6 months ago when I reached out to Intel about supporting us with some chips. A low-power Xeon to build the high-speed storage server for our new office that I first showed off here. Then a pair of their top-of-the-line E5 2699 V3 18-core Xeon processors to build a network video rendering server, also for the new office. Well, as it turns out, they couldn't send us the low-power chip for the storage server, so we bought our own. But whatever the reason was, they were able to honor our request for the pair of $4,500 processors. So it is with much thanks to Intel, along with Supermicro, who provided a dual-socket motherboard, Kingston, who provided 128 gigs of DDR4 ECC RAM, and Norco, Noctua, and FSP, who provided our case, cooling, and redundant power, that we are able to bring you these findings. Because you see, the deal was this. Send us the chips and we'll make a video about how we're using them, which sort of puts a lot of pressure on us to figure out not only if the concept of network rendering, also known as a render farm, works. I mean, that's been pretty standard stuff for years, especially in animation, but also to find a way to efficiently use those resources in our workflow. So without further ado, thanks to weeks of work by Edsel and much patience from the rest of the team, I am pleased to present our new editing workflow. It's fast, it has built-in redundancy for our files, and to quote Dimitri from Hardware Canucks, who has already switched to it, it brought the joy back to 4K video editing for me. So here we go. So the most obvious bottleneck in a video editor's daily life is waiting around for encoding tasks to complete. Outputting a finished, ready to upload H.264 video file can take anywhere from 15 to 30 minutes for us with one pass VBR, or even over an hour with 2 passes. So that was the first thing we tried to tackle with the 36-core server machine. For software, Telestream Episode and Sorensen Squeeze Desktop were the frontrunners initially. Telestream was intriguing thanks to its unique ability to split an encoding project into pieces, process them across many cores, and then stitch them back together at the end, regardless of the codec. And Sorensen, due to its excellent handling of multiple concurrent projects, also a time saver if you have many processing cores, and its ability to utilize all cores for a single project with supported codecs. So Episode is a great concept, but we abandoned it quickly due to stability issues. Sorensen, on the other hand, impressed the snot out of us. The software worked, their support staff was professional, and even as a trial customer, we were escalated to engineering whenever we encountered more complex issues. Outstanding. So next, we tested a variety of different output formats and found that thanks to optimizations within Premiere Pro, our projects could be exported very quickly by our editing workstations in DNxHD to our server, where Sorensen would utilize all CPU cores to output an H.264 master copy that was suitable for upload to YouTube and other video sharing sites in a fraction of the time that Adobe Media Encoder could do it. And all of this while leaving the video editor's computers free to work on other things instead of just sitting there barely usable while they encoded video. So mission accomplished then, right? Well, you know how the rabbit hole is. The discoveries we made about how dramatically a program's optimizations around a given codec could affect performance raised more questions than they answered. And while Premiere Pro's claim to fame is that unlike competitors like Avid and Final Cut, it allows any video file you want to simply be plunked onto the timeline and edited in real time, it made us consider the way that 4K footage off our Panasonic GH4 camera just seemed to chug as you scrubbed through it on the timeline, even on 6 CPU cores and a 10 gigabit network connection. Maybe there's some merit then to going back to the old way. So we devised a workflow that would utilize our copious amounts of CPU horsepower to transcode footage from whatever format our various cameras captured in natively to an intermediary or mezzanine codec that was compatible with all the programs in our workflow. So for a number of reasons, Avid's DNxHD was chosen, and would you look at that? Comparing prefetch latencies with native GH4 footage, the delay when moving the playhead in Premiere was reduced by nearly 25 times at 4K, depending which program exactly was used for the transcode. So it was at that point that the goal actually changed. Obviously, we could just have the individual video editors convert all the footage off the cameras to our mezzanine codec when they're working, but then we'd be right back where we damn well left off, with highly skilled video editors staring at their barely functional computers, waiting for a big queue of videos to transcode. So no, we needed a way to avoid that by using our overpowered hardware. And the answer, of course, is to do the transcode at the time of ingest, or when the footage is initially removed from the camera. And here's some bad and some good news. While Squeeze Desktop, Sorensen's low-end offering, can perform a task like this across many CPU cores, because we dump so many video clips off our SD cards at a time, it just wasn't stable enough with our workload. So we turned to their server offering, which operated much more smoothly, to automatically monitor our video file dumping folders and transcode everything we dropped in them. So the benchmark was a folder of 41 video files totaling 16.7 gigs, and by prioritizing multiple tasks, this could be processed in about 14 minutes. A small price to pay, even on a video that needed to be edited immediately for the improved timeline performance. But unfortunately, time wasn't the only price. The server version requires a Windows Server operating system to run on top of and costs $5,000 plus yearly maintenance fees. And furthermore, despite the assurance we received from Sorensen's engineers that there shouldn't be any gamma or color shifts using QuickTime as a wrapper between Squeeze's DNx HD export and Premiere's import, it was there and very difficult to compensate for. So it was back to the drawing board somewhat, which led us to a conversation with Blackmagic Design, where they said that Cineform could also be a great mezzanine codec, an option that had been dismissed early on due to its limited compatibility with most software, including Sorensen Squeeze, although they had said they could add compatibility with the next yearly release. So could we quickly transcode our footage to Cineform? It turns out that yes, even with only 30% CPU utilization, effectively 10.5 of our 36 cores, Adobe Media Encoder, yes, back to that again, managed to kick Sorensen's ass, converting to Cineform versus Sorensen converting to DNx HD. And all of this without a significant loss in quality, regardless of whether we're working with native 4K footage for better green screen and punch-in performance, or settling for upsampling 1080p footage for our finished project. By the way, please see this video for more details about the benefits and the drawbacks of 4K. So that's all fine and good, Linus, but does Cineform deliver? The answer, again, yes. While file sizes are significantly larger, especially at 4K, than even the source files, timeline performance is better than even DNx HD thanks to an extraordinarily poorly documented feature of Cineform. It's GPU accelerated. So even though DNx HD also performs like a champ, it can eat 50 to 60% of a 12-core Xeon while scrubbing through footage, while Cineform is using the fancy Titan X graphics cards that NVIDIA sent us for our workstations to keep CPU usage much lower. So then here is the process that we finally settled on. We're using Adobe Prelude 2015 to ingest our footage, automatically dumping the raw files off of the camera to a local storage array on the machine in case of an emergency, and then queuing up transcode jobs for each of those clips in Media Encoder 2015 to send to our network share. We then use Media Encoder 2014, which is included with your Creative Cloud license, by the way, to monitor the watch folders that we export our finished jobs into and turn those into H.264 files ready for publishing on websites like YouTube, Vessel, Youku, Bilibili, and Facebook. And while hitting both instances of Media Encoder, we've seen CPU usage as high as 90%. But that doesn't mean that you need a multi-$1,000 network render machine to utilize this workflow. All we've demonstrated here is that it's scalable to that kind of hardware for a small team. You could easily take advantage of this on a smaller scale with a low-power networked machine if you just wanted to improve your timeline performance and not sit around waiting for exports on your main station while something else works on that in the background. Thanks for watching, guys. If this video sucked, come on! This was a lot of work. But if it was awesome, please hit that like button, get subscribed, or even consider supporting us directly by using our affiliate code to shop at Amazon, buying a cool t-shirt like this one, or with a direct monthly contribution through our community forum, which you should definitely join, links up there. And now that you're done doing all that stuff, you're probably wondering what to watch next, so click that little button up in the top right to check out Luke's video where he goes through the ins and outs of password protection. That is, protecting your passwords, making it so other people don't have them. See you next time.